Hey, boys and girls, it's Mr. McAndrew, the math coach. But you already know that. I thought we would review your work from Wednesday kind of briefly and then get into our work from today. There will not be as much today as there was on Wednesday. I know there was a heavy math day. But anyways, yeah, good stuff. And let's get started. So, four multiples of 10 between 0 and 100. There's a lot of answers for this. I put down 30, 60, 90, and 100. You could have had four different ones. Why is every multiple of 10 also a multiple of 5? The only reason I didn't write that down was there's no like one way to write that, but something to the effect of the fact that because 10 is a multiple of 5, right? Because 5 times 2 is 10, then it has to be true that every multiple of 10 is also going to be a multiple of 5. And we know from looking at our chart, right, that all multiples of 5 end in a 5 or a 0. And all the multiples of 10 end in a 0. Okay. Circle the numbers below that are multiples of 3. So I've circled the ones that are multiples. There's one that I did not circle yet because I wasn't sure, right? 93. But if I use the pattern we saw the other day, okay, let's see, 9 plus 3 equals 12, and 12 is a multiple of 3. In fact, if I do 1 plus 2, I get 3. So 93 is a multiple of 3. And you could have used, if you used your chart, you would have seen that 93 is a multiple of 3. Okay. Four multiples of 6. Well, there's a lot of them. I just put down 6, 12, 24, and 36. Are all the multiples of 6 you wrote down also multiples of 3? Yes. Yes, they are. For the same reason that all multiples of 10 are also multiples of 5. Four multiples of 9, I put down 9, 18, 36, and 99. You may have had four different ones as long as they are multiples of 9. And again, just like with 3's, if you add up the digits, it gives you a multiple of 9. Like 9 plus 9 is 18. 6 plus 3 is 9, etc. And yes, all the multiples of 9 are also multiples of 3. Okay. On this page, multiples of 2 end. We know this in 0, 2, 4, 6, or 8. Okay, they're all even numbers. We can see that on the chart here. Okay, all even numbers. Multiples of 4, there's a lot of them. I put down these ones. And if it's a multiple of 4, it has to be a multiple of 2 because they're all even. Okay? Here's some multiples of 8. And yes, all multiples of 8 are also multiples of 2 and multiples of 4. It doesn't mean that all multiples of 2 are multiples of 8, right? Like the number 6 is not a multiple of 8. But if it's a multiple of 8, it has to be a multiple of 2. All right, don't get confused there. Okay. 42 is a multiple of 6 and 7. We already knew that was true. All the multiples of 5 end in a 0. False. We just said some of them end in 5. 93 is a multiple of 3 because 9 plus 3 is 12. Didn't we just do this? We just did it over here. Yeah, we just did it. That's true. We know that's true. Okay. All multiples of 4 are also multiples of 2. We just talked about that. That is true. 58 is a multiple of 8. Wrong, false. Okay, I mean, that is the correct answer. But no, it is not a multiple of 8, even though it ends in an 8. 56 is a multiple of 8 because 8 times 7 is 56. Multiples of 7 include 14, yes. 35, yes. And 61, no. 61 is not a multiple of 7. 9 times 7 would give you 63, so that is false. And if a number is a multiple of 2 and 3, then it's also a multiple of 6. That's true. If it's an even number and it's a multiple of 3, it is automatically a multiple of 6. Okay, the challenge puzzle. The answer is, drum roll please, 48. Okay, it is a multiple of 2 because 2 times 24 equals 48. It is a multiple of 4 because 4 times 12. It is a multiple of 6 because 6 times 8. And it's a multiple of 8 because 6 times 8. Okay? All right, so let's get into our next challenge. Okay, all you need are 13, you heard me, 13 square inch tiles. So take out 13 square inch tiles right now and come back when you're ready. I'll see you in a minute. All right, your challenge, if you choose to accept it, and I want you to accept it, is this. I want you to find as many rectangles like we did the other day on Monday, okay, with an area of 13. Okay, find as many as you can. Okay, has to be a rectangle. So, for example, right, like this, for example, is not a rectangle because it's not filled in, right? Doesn't make, oh, sorry, I'm not, you were just looking at me doing it. This is not a rectangle because look over here, it's missing a couple tiles, okay? So that doesn't work. But see how many you can make, all right? Take a couple minutes and come back and report out what you find, all right? I'll see you soon. Girls, I am trying to find rectangles for 13 and I am not doing well. I'm just about in tears here. What's going on? Did you find any rectangles for 13? Oh, my goodness. I think there's only one that I've found so far, which is just to put them all together in one big row of 13 like this. I mean, that's a rectangle, right? Can you find... Oh, it's going off the camera. My goodness gracious. Can you find any more rectangles? I mean, I can't. What does this all mean, boys and girls? Well, I'll tell you what it means in just a second. All right, so I got all of them in there. Okay, there's 13. What it means is that there's only one rectangle you can make. I know, I kind of tricked you because I was like, how many rectangles can you make? Made it sound like you could make more than one, but you can't. There's only one rectangle you can make. There's a reason for this. It's because it is a prime number. Mr. McAndrew, what does prime mean? It means you can only make one rectangle. That's it. Okay, it only has two factors. 1 and 13. That's it. Not 2. Not 3, not 4, not 5. Nope, just 1 and 13. That's it. Now, there's a lot of prime numbers. I mean, there's more numbers that are not prime. Okay, but there are a lot of prime numbers. All right, let's do one more like this. Now, take one of the tiles away. Just one tile away. So now you have 12, okay? Now see if you can make a couple different rectangles. You should be able to make more than one rectangle. So just, I know you've done this before, but just do it real quick. It's only 12 and see what you get and then come back. All right, so, I mean, here's a rectangle you could make, right? 2 rows of 6, or you could do 3 rows of 4, or you could do 4 rows of 3, or you could do 1 row of 12. So there's lots of rectangles you could make. So that 12 is not prime. We call numbers like that composite. Composite. Okay, all it means is it has more than 2 factors, right? Prime has only 2 factors, 1 and itself. Composite has more than 2 factors. You could make a variety of rectangles, okay? If you try to make rectangles with the number 7, okay, you will see that there is only one way to do it, which is just like the number 13. There's only one way to do it, like this. So 7 is prime. It's 7, 13. Composite would be 12. I mean, most numbers are composite, right? Okay, but prime means you can only make one rectangle and it's only got 2 factors. Okay, so let's look at this on a hundreds chart. So in your packet, you have a big hundreds chart that looks like this. So take that out and we'll finish up. All right, so boys and girls, we're going to find all the prime numbers between 1 and 100. How are we going to do that? Well, here's how we're going to do it. We're going to cross off all of the multiples of 2, 3, 4, 5, 6, 7, 8, 9, and 10. Cross them off. And that should leave us with all the multiples. All the primes. Because a prime number, remember, only has two factors. 1 and itself. Not 2, not 3, not 4, not anything else. So, for example, if I crossed off all the multiples of 2, like this, then I would go like this. And I'm just going to kind of go down like this. In fact, I'm just going to go boop, 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 boop. All right, so you're going to do the same thing, okay? Because this will help you to locate prime numbers. So it can't be any of the even numbers. None of the even numbers are prime. All right? Okay. Now let's go to the 3s. Let's cross off the 3s. 3, 6 is already done. 9, 12 is done. 15, 18 is done. 21, 24 is done. 30 is done. 33, 36 is done. Okay, 39. 42 is done. 45. 48 is done. 51, 54, 57 needs to be crossed off. 60 is done. 63, 66, 69. If I'm going too fast, just pause the video and take your time and just cross off all the multiples of 3. Some of them are already crossed off. Right? Every other one's already crossed off because we did the 2s. 72, yep, 75, 78, 81, 84 is done, 87, 90, 93, 96, 99. Okay, so we're getting there, right? Let's cross off all the multiples of 5. We don't need those, right? Because those aren't prime. Some of them are already crossed off. Okay, so we know those aren't it. How about the 4s? Did we get all the 4s yet? Let's see. 4, 8, 12. Yeah, we got all the 4s already because we crossed off all the even numbers and all the multiples of 4 are even. So those are all done. We did the 5s. The 6s. There might be some 6s left. Let me check. 30, 36, 42. Those should be done because yeah, they're all done because we've crossed off all the multiples of 2 and 3, which means all the multiples of 6 would be crossed off. 7. Let's look at the 7s. Let's cross off. Okay, so cross off. Oh, you know what? Oh, shoot, I made one mistake. Don't cross off 7. Okay, but after 7, let's cross off 14. We got that. 21, got that. 28, 35, 42, 49. Oh, 49. Let's cross off 49. Okay. Let's see. Do we have any others? Let me just check. We got 70. Let's cross off 77 because 7 times 11 is 77. 84 and then 91. Okay. And that should do that. Okay. And then the 8 should be all set because we already crossed off all the 2s and 4s. And the 9s should be all set because we already crossed off all the multiples of 3. Okay, so now let's circle any numbers that are left over. All right, so these are the ones that are left. If you circle all the ones that are left, these are all prime numbers. You can only make one rectangle with these numbers, and there's only 2 factors, 1 in themselves. We should also circle the numbers 5, okay, because it only has 2 factors, 1 and 5. The number 3, okay, because that only has 2 factors, 1 and 3. I shouldn't have crossed that off in the beginning. I'm sorry about that. All right, and there's one more prime number, which is 2. Okay, 2 is the only even prime number, right? You'll notice all the other ones are odd, because if they were even, they would be divisible by 2, and they would have that factor, and they wouldn't be prime, because the only 2 factors of a prime number are 1 and itself. So these are all your prime numbers, okay? All right, so for your homework, not your homework, your independent work. All right, so you'll have 2 pages, this page and this page. Use the charts that you have to get this done, okay? You've got your prime numbers, and you've got your many hundreds charts, and your square inch tiles if you need them. I did want to call out one other mistake I made. I apologize. This should be 19, the number 19, and it should be circled as a prime number, okay? All right, boys and girls, great job this week. We covered a lot of material. Hope you're doing well, and I'll talk to you soon. Bye-bye.